we go. So, adding and subtracting polynomials. You're going to add and subtract polynomials exactly the way we've done this before. I don't care. Scribble this part out here. I don't care. You guys are good with this. We don't need zero pairs. We're just going to talk about adding and subtracting these things. So, this looks an awful lot like that we've already done before. It looks kind of like grouping. When we're adding things together, so I've got 2x squared plus 3x minus 4 plus 3x squared minus 4x plus 2. If I told you to add those two things together, what do you think you'd do? Okay, so you're suggesting we get 5x squared. Where'd you get the minus x from?
3x minus 4x.
A positive 3x minus a 4x. Cool. So that's going to give us minus x, and then minus 2. So we've done these already. Yes, we're cool with what just happened. Okay, it's grouping. That's really all it is at this stage. Adding and subtracting polynomials. That's it. So someone rattle off this second one here for me real quick. Carolyn, cool. X squared. Okay. Questions of how that happened? Going once, twice, 3 times. Sold. Okay, cool. Yes. Now, subtracting polynomials. Subtracting polynomials is going to be similar, except what do you think we're going to... Take a look at how this is written. We've got one polynomial minus a whole nother polynomial. Hands up, does anyone think they've got an idea of how we'd go about dealing with this thing? We're going to have to make sure we subtract everything, and to do that, what we're going to do is we're going to distribute that minus sign in. So this guy here, we're going to multiply him in like a negative 1. And so what we're going to do is we're going to get, once we've done that, we can drop the brackets, and we're going to get something that looks like this. 3x squared plus 5x minus 4. The first bit doesn't change. But then we're going to get minus 2x squared minus 4x. And then when you subtract a negative 2, that's the same thing as adding 2. It is subtracting, but we got to be real careful how we do it. Was that Nika who said that? Is it not? It is subtracting, but we got to be careful how we do it. To make sure we do it properly, we're going to distribute that. We're going to distribute subtraction in and give her. Yes, Carolyn. So then you've got the 3x squared, and the negative 2x squared is going to give you x squared. And then, Carolyn, you said it's going to be plus x. That came from this plus 5x and this minus 4x. And then minus 2 because of this negative 4 here and this plus 2 here. Cool. Relatively straightforward, yes? Questions about any of the techniques here? Okay, then I want you to rattle off 2, 3, and 4 for me real quick. Carolyn, you got number 2? You finished it. Okay, what's number 2?
4x squared minus 5x minus 4.
Carmen, you done too? You look like a woman who's confidently completed this. Okay, what'd you have for number 3? Well done. That is correct. And then someone else who completed number 4. Let's go to Urea. You look like you confidently completed number 4.
Negative 7x squared plus 5x minus 3.
Cool. Comments, questions, concerns about any of those? Those are all correct. Well done. Did anyone get something different, want to see this in perhaps a little bit more detail? This is fairly straightforward, yes? Oh.
Just like really detailed, like just like number 4.
Sure. So with number 4, what we want to do, and the place where you guys are likely going to get messed up is if you're not willing to show your work. The more you do in your head, the more likely you are to make a simple mistake. So we want to distribute in this subtraction onto the entire second polynomial. So what we're going to get, I'm going to go below the correct answer here. What we're going to get is we're going to get negative 4x squared plus 3x minus 2. The first polynomial doesn't change, but then we're going to have negative times 3x squared, so it's going to be minus 3x squared. Then the negative negative is going to give us a positive 2x, and then minus a positive 1 is going to give us minus 1. And now we're going to group. Negative 4x squared and negative 3x squared is negative 7x squared. 3x plus 2x is 5x. And then negative 2 minus 1 is negative 3. See the procedure there? Okay. So addition, subtraction, not too bad, yeah?
Oh, no,
Let's multiply and divide. Flip the page. Actually, we're just going to do multiplication, I think. Yeah, we're definitely just going to do multiplication. Okay. Oh boy. And then lots of practice, apparently. Here we go. So, multiplying polynomials. What else can I take a look at today? So the addition and subtraction, I'm hoping you're relatively comfortable with. If you're not, please do say something. Happy to assist you. But I want to start jumping into the meat and potatoes bit here. So we're going to get rid of this. Forget that this top line happened. We don't need to warm up because we've done it already. We literally just did it. You've kind of done some of this already too. The exponents are going to get a little bit bigger, but ultimately, if you combine what we did in the exponents unit with what we did in the equations and inequalities unit, you've seen some of this stuff already. If I had something like this, 3x squared y cubed times 6x to the 5 y to the 8, and I want to multiply those things together, what am I going to do? What is the technique for this? Is that you, 10 meat, or is that Angel? Angel. We're going to add exponents. Where are we adding exponents? So when I multiply the x squared and the x to the 5 together, those are the same basis, so you're suggesting I add those exponents together? Okay. So what's that going to give me? X to the power of 7. And then y cubed times y to the 8 is going to give me... Oh. Ah, okay. We have this is a time long gone by. So what I'm doing is I'm multiplying this whole piece by this whole piece. Okay? So think back to our exponents unit. It's related to what we've already done. When I multiply this whole expression by this whole expression, there's only certain parts that can multiply together. Like when I write 3x squared y cubed, this is the same as 3 times x squared times y cubed, right? Are we cool with that? I'm talking too fast. I'll slow down. This expression right here is the same as 3 times x squared times y cubed. Yes?
Okay, yeah.
We're cool with that? And then this one is going to be 6 times x to the 5 times y to the 8. Yes? And what am I doing with these two expressions? I'm multiplying them. So what do I have here? I have a long string of multiplication. And I'm allowed to multiply in any order, right? If all I'm doing is multiplying,
Wait, so you're starting with...
I can choose what order I'm going to multiply in, right? So what I'm going to do here is I'm going to multiply the things that can actually combine nicely. I'm taking my x squared and my x to the 5, I'm going to multiply those together. When I multiply the same base, what do I do with the exponents? Add them. So, and then I'm going to multiply these two together. The y cubed times y to the 8, because the y's you can multiply together, they're the same base. It's going to give me y to the... And then the last thing that I can multiply together is going to be my coefficients. I'm going to multiply 3 and 6, and it's going to give me 18. So 3x squared y cubed times 6x to the 5 y to the 8 is going to be 18 x to the 7 y to the 11.
I just didn't understand what the 3 and the 6 were, but now I
Well, I think Acom just started, or it was Acom or Angel, I can't remember. We just started with the x's and the y's. We came back to the coefficients there. We follow the technique here? Okay, so let's go back to here. Number 2. What's that thing going to look like then?
The same thing.
Okay, so the negative 6 and the 2 are going to multiply together. My coefficients is going to give me negative 12. Then my a to the 4, good, because if there's no exponent written, the exponent is a 1. Love that. And then b to the 5 and b to the 4 is going to give me b to the 9. Okay, cool. Relatively straightforward, yes? So we're going to hold off on number 3 because 3 is the same as what we've done here. It's just got more variables. So let's do, hold on. We'll do one more. Down here, I want you to write this question down. Negative 4a squared b cubed times negative 2b squared c to the 4. Those are the two things we want to multiply together. How is this one different than the previous two? Acom. There are 2 variables that don't have matching bases. So which ones don't have A and C both don't have matching bases. So when we multiply these things together, well, yeah, what are we going to get here? I'm going to get negative 4 times negative 2 is 8. A squared times, well, nothing, times 1 is a squared. My b's can get multiplied together. It's going to give me b to the. And then my c has nothing to group with, so it's just going to get tacked on to the multiplication as well. I'm going to have 8 times a squared times b to the 5 times c to the 4 is what this thing's going to turn into. Nice and simple, right? Where things get a little bit wild and wacky is when we start multiplying larger polynomials together. That was a monomial times a monomial. Now we're going to do a monomial times a polynomial, and then we're going to do polynomials times polynomials. It's going to be great. So, if I've got something like this, 3xy bracket 2x minus 6x squared y plus y squared in brackets, what do you think we might do with something like this? We're going to distribute. Very good. So we got to be careful how we distribute. This, what I did up here, this is not distributing. This is just multiplying in whatever, in any order I want and grouping same bases. This one is a full-on distribution. If I'm multiplying this monomial by this polynomial, I want to make sure that I multiply this onto every term in the polynomial.
The whole thing, or just y?
This whole thing gets multiplied. That whole monomial gets distributed onto every term inside our polynomial.
But why not just the y? What is so different?
It's all multiplied together. If it's 3xy, is the same as 3 times x times y, and it's 1 term.
Yeah, so that whole single term is going to get multiplied onto all of these individual terms. So Carolyn, what am I going to get?
3xy times 2x squared
Which is?
is 6x squared y.
6x squared y is going to be my first term. Look at, so what we multiplied the 3 and the 2 together. The x times x is x squared, and then the y doesn't have anything to group with, so it stays just y. Keep going, Carolyn.
And then it's going to be negative a x cubed and y squared.
Okay.
And then it's just 3x y cubed. And then we can add it to that.
And then we can group if we can. Is there anything here to group? Careful, we can only group terms if what? No, we can only group terms if we have the exact same variables with the exact same exponents. So I don't have that. I've got x squared and I've got a y here, so I cannot add that to x cubed and y squared. I can't add that to x and y cubed.
Oh, I see.
These are not like terms. We had a whole discussion about like terms at the beginning of the last chapter. They're not like terms, so I cannot group them.
So they just stay like that?
So this is it. We are done. This is a trinomial. Looks gross, but this is what it is. Does this make sense? Kind of, sort of? So try this one on your own here. Let's see what you get. What'd you get?
Negative 6a squared. No, 2b squared. Take away 4a. b cubed. Take away 20ab squared. Oh, it's plus 20ab squared. Yeah, I saw that.
Do you understand why it's 20 AB squared? Not.
Yeah.
Okay.
Because it's negative.
So it's like monomial multiplication, but you're just doing it 3 times. We cool with what's happened here? Comments, questions, concerns about what Amanat did? Oh, and Acom? We good? Okay, cool. This is where I'm going to stop us today because we've only got 5 minutes left. We'll pick it up here tomorrow, and things are going to get more interesting here. So what I'm going to get you guys to do, I want you to practice some of this stuff. If you flip back here, there are 4 addition questions I want you to take a look at. This is going to be homework. If you want extra practice, I have more practice, but I think the addition and subtraction stuff is pretty easy for you guys. And then I want you to flip ahead to this page here. Multiplying polynomials. And I want you to do I want you to do 1 to 13. That's it. But this is homework for Thursday. I want you to do 1 to 13. We'll look at binomial and bigger multiplication tomorrow when we've got a little bit more time. How come we're not doing? Because look at 14. That is different. We will do, don't scribble out 14. We're going to do 14 tomorrow. Okay. We are going to do 14 eventually. But we're just starting with practicing monomial multiplication and the monomial by a polynomial multiplication. The binomial stuff will start tomorrow. So that's it. Thanks for humoring me with some math games this morning. I got a whole book of more of these things, so we'll see how it goes. Do not pack up till the bell goes. I do want you to get started on this. Market Set Giver. You get most of this done by the time the bell goes.